Hello there. Logistic regression is one of my favorites, and one of the reasons why it is my favorite is the mathematics involved in it. If you have forgotten your high school level mathematics, then it might be a little difficult for you to understand this. So, I will first take you to the basic mathematics you need to understand logistic regression. Don't worry, I'm not going to take much time. I will only explain what is must for you to understand logistic regression. So let's begin. This one all of us understand. 10 to the power of 2 is equal to 100. It is very difficult to forget this part. So I hope all of us understand this and it does not need any more explanation. And if I say log of 100 to the base 10, that means I am saying what power of the 10 will make 100. And the answer of course is 2, as we have seen here, right? And in such case of log where the base is 10 is called common logarithm. What if I just write log of 100? I don't write base 10. Then what happens? In such cases, the base is assumed to be number 2.718, that is E. And such kind of logarithm is called natural logarithm, and it is also written as ln 100. That's it. That is the basic mathematics I was talking about. Now that we are on same page, let's move on to understanding logistic regression. Before we jump on to logistic regression, let's take a step back and let's understand what did we do in linear regression. In linear regression, we saw this formula y equal to b0 plus b1 bn xn, right? And we understand that the right side of this equation is continuous number. The x1, x2, x3 and beyond, these are all continuous numbers, and the result of this whole equation along with coefficient is a continuous number. And the outcome will also be a continuous number. You have worked on the cases of predicting fuel efficiency wherein there were independent variables like which were various features of the car, and you came up with the predicted fuel efficiency which was a continuous number. So input continuous number, output continuous number. Let's come to logistic regression. Logistic regression, even though the name says regression, it's actually a classification algorithm. And by classification I mean the outcome is not a continuous number. So let's begin. On the right side it is same. It is still same continuous number. So outcome of this side will be a continuous number. But on the left side, because it's a classification technique, the outcome has to be a binary outcome in case of logistic regression. So binary outcome means values like yes, no, right, wrong, 0, 1. So that kind of outcome. The complexity here is how do you get a binary outcome with the continuous numbers. And that's where the whole fun behind mathematics start. In case of logistic regression, y is replaced with something like this, log of p by 1 minus p. And this one here, this is probability. P means probability. And this whole thing, p by 1 minus p, is called odd of outcome. So odd. So, and the log of this value, remember there is no base to the 10. So this is a natural log. Yes. So this one is a natural log. And so the formula is changed. Now y is replaced with log of p by 1 by p. So that is the formula here. That means log of p by 1 by p, where p is a probability, is equal to y. And if I further expand it, then I come up with this formula that p probability is equal to 1 by 1 plus e raised to minus y. So now this is the very interesting part. Why did I do all this? Because in this formula, no matter which value of y I put, I will always get a probability value, and probability value will always be between 0 and 1. So that means I can still get outcome of this as a continuous number, which will be my y, but the moment I put that y in this equation, I will get the probability value, which will be between 0 and 1. You don't believe me? Okay, let's do this. I put several y values here in this formula, and this was my outcome. This was my p value. You can experiment with more y values, and this was the graph. So now I have a graph of probability values ranging from 0 to 1. Right, these are my probability values and these are y values. So probability value is 0 to 1, right? My graph is looking like this. And then I can follow a simple formula that if my probability value is less than 0.5, I will say no, and more than 0.5, I will say yes. Yes, and right here, I changed my outcome from continuous number to binary outcome, yes and no. And that is why I like logistic regression. The basic mathematics has made a continuous number outcome to a binary outcome. So welcome to the logistic regression. I will see you in next lecture. Hello there. Welcome to this lecture and congratulations. The fact that you are in this lecture indicates that you have finished a regression analysis and KNN classifier. You should congratulate yourself. You are making a pretty good progress. So let's begin. We are going to first import all the libraries, right? Let's do that. But before that, let's name our notebook Logistics Regression Demo 2 students for me to remember. Okay, and now import the libraries. One thing I must say, while you are with me, please practice all this command and type it. Do not copy and paste. The reason I am insisting on you type it, because you should develop the habit. You should remember all this command by heart, because when you go for interview for data science or machine learning job, there is a very high chance that they will ask code. So they will give you a problem and they will ask you to develop an algorithm, and you might not have the privilege of copy and paste there. So that's why make use of all these lectures. I am typing here, follow me and develop the habit and type each and every command. These things you should remember by heart by now. Okay, I have done it several times, so I'm going to go very fast here. Import numpy as np, import pandas as pd, import matplot lib dot py plot as plt. Okay, next we are going to read our file pd dot read csv and r. Over here give the file name along with the directory. When you downloaded the file, you might have got two files, the bank full.csv and bank additional.csv. The full one has about 400,000 records. It's too big for you to experiment upon. You can do that, but if you are doing it on your own computer, several things like analysis and the if you're writing or plotting a chart, those things will be very slow. So that's why I suggest use this bank additional.csv, which only has 4,000 records. And delimiter in this case is semicolon. Okay, let's see we got it right so far. Run this, yes. Something is not right. Oh, here it's a semicolon. Let's do it again. Here we go. 21 columns. So there are 20 feature values, and y over here, that is our target variable. Yes, no, it will have the values yes and no. So it says whether these employees bought the bank deposit product or not. So far so good. Now let's start data exploration. Data. What do we do? The first thing is we check the shape of our data. df dot shape. 4119 rows, 21 columns, awesome. Next we are going to see the correlations. Over here, let's see age, pretty good, not correlated with any column. Duration looks pretty good. Campaign pretty good. Pay days pretty good. Previous pretty good. Employees variation rate looks like it is dependent on employed and this one, but we know that this employee variable variation rate, this is going to be based on whether the guy is employed or not. So I think this should be fine. We don't have to remove any of this. I think overall it looks good. We can move on now. Overall data exploration looks good. I think we can go to data preprocessing now. And data preprocessing, the first thing we are going to do is label encode all these variables. But before that, let us separate our x and y, because we are going to label encode only x, the independent variables, not y. Okay, so it's very easy. Y is going to be this target variable y here. So y is very easy, df y, that's y, and x is going to be everything but y, right? Okay, df dot drop y axis equals 1. Very good, we got x and y right. And next thing we're going to label encode x. So from sklearn dot preprocessing importing label encoder, and next of course we are going to create instance of label encoder. So far so good. So there are 21 columns, out of which 20 are feature values. So we have to encode 20 columns here. I'm not going to write each one of them one by one. Instead, this time I'm going to use a for loop. So for I in range length of x dot columns. So this will return 21 because there are 21 columns. Okay, so this loop is going to run for 20 times. X dot ilog lbc dot fit transform x dot ilog. Let's run this. Let's see, we got all the columns encoded. Looks good, but look at the values. 12, 1, then 474, then 156. So they all are on different scale. So let's put them on the same scale, right? So let's do that. From sklearn dot preprocessing import standard scalar. And over here also, first we are going to create an instance of the standard scalar class. stdcl equal to standard scalar, and then we are going to transform tdcl dot fit transform x. Let's run it. Pretty good. And let's see, review the head first few records. Now this standard scalar has converted this x into array. Like if I see here, now it is array. It is no more a pandas data frame. That's why when I put head, it gave error. So to see first few records, we have to first convert this to data frame, pd data frame x, and then over here we say head. Let's do it now over here. Okay, very good. So all of them look on same scale now. They are around 1. So either less than 1 or around 1, right? Looks good. Now it's the right time to split our data in training and test data set. Let's do that. From sklearn.model selection import train test split x train x test y train y test is going to be train test split x and y test size is going to be same 0.2 and random state is 0. Very good. And let's print the shape of each of them. X train dot shape x test dot shape y train dot shape y test dot shape. Very good. We got x train x test y train y test. Now it's time to train the model. From sklearn dot linear model import logistic regression, and we're going to first create instance of logistic regression, logistic regression, and then we're going to fit lrc dot fit x train and y train. Very good. So our model has been fit with the training data, and now let's test the model and predict. Y underscore pred is going to be lrc dot predict x test. Awesome. So we got our y prediction. Now let us test the accuracy of our y values, how accurate we got it. So from sklearn import matrix, print accuracy matrix dot accuracy score y, and let's print our lrc dot predict x. lrc here. So instead of just putting x test, we are going to predict on complete x and compare with actual y value. 91%. I must say this is a very good score. So logistics regression fit very well for this dataset. Let's see the comparison of actual values with the predicted values. Very good. So we are going to create a new data frame df3 with actual and predicted values. pd dot data frame actual value is going to be y dot values and predicted values are going to be this guy lc predict dot x, and it is going to go here, and then let's print the df3. Actual and predicted are matching. If I say first 15 rows, it's all matching. So why not write something so that we can compare the actual and predicted for all 4119 records. Let's do that. We are going to write a small Python code to compare our actual values with the predicted values for each 4119 records, and it will give us the number of records for which actual does not match with the predicted values. So let's begin. First we are going to set our counter to 0, and then after that we are going to run a for loop for I in range length of df3, which is going to return 4119 here. So I is going to run from 0 to 4119, that is for all these rows, and we're going to compare actual with the predicted. So if df3 dot ilog I0, which is actual, is not equal to df3 dot ilog I1, which is predicted, then increment the counter by 1, and at the end we are going to print the counter. So let's run this. Over here 356 records. So that means out of 4119, only 356 records do not match with the predicted value. So the actual does not match with predicted for 356 rows. That is very less for 4119. So you got a very good model. Of course, I understand this 356 we could have calculated based on accuracy also, but I just wanted to show you that you can also write a Python code to do the same. And the advantage of writing Python code is that you can actually see all those records where these values not match. You can print all those df3 ilog here and see all those records. Good. Congratulations once again, you have finished logistics regression, and with the success rate of 91%, you were able to predict whether the customers have bought the bank deposit product or not. You can use the same thing, same logic in other dataset, likewise datasets, and practice it. Good job. I will see you in next lecture.